Okay, this is part 2 of graphing a system of inequalities. I accidentally turned off the recording. We're going to try it one more time. Ready? Pause the recording and try graphing the next 2. All right, let's look at this. I'm going to remind you, when you have something like y equals 3, remember if I had the equation y equals 3, I'd make a table, and that means y is always going to be 3. And I choose my x's. If I had something y is less than 3, then I would make my table, and my 3's would go here. But it says y is greater than 3, right? Y is greater than 3. So I usually do that, make the table. The other thing you could have done is, but I just watched a student, your m is 0, and your b is 3. So, but what does that mean? 1, 2, 3, right? But now I can see 0, 3, 1, 3, 2, 3. Is this solid or dashed? Okay, it's dashed. Now, my PowerPoint doesn't make the table, but I think that's usually the better thing to do. It's dashed, and it will be, are we shading up or down? Up. So we're going to shade up. And then on the other one, my m is -2, my b is 1. We're going to start at 1, and we're going to rise down 2 over 1, down 2 over 1, down 2 over 1. Did you do that correctly? Yeah. Okay. And then we end up shading down, and it is dashed. Did you get the right part? Yeah. Okay. Questions? All right, so let's just look at a couple of others. I'm going to remind you, you don't do these in standard form. Do not use graphing using intercepts, because you still will have a problem with the shading. So still, get your y alone for each problem. Get y alone. Find your m, find your b, and then do your shading. Is everybody clear on that? Get my y alone. Remember, let's look at right here what's going on. Remember, when I got my y alone and I divide by -1, what do I have to do? I have to flip the inequality, right? The inequality gets flipped. You guys with me? Yes or no? Okay. And then doing our double shading. All right, sometimes they might give us 3 inequalities. So sometimes you may have 3 inequalities. Okay, you're doing the same thing. If you have y is greater than, what is y always going to be?
Greater than -2.
Right, y is always going to be -2. If I make my table, so in that one I'd be doing, x, here's y. It's -2, -2, -2. On the other equation, x is less than 3. I'm going to be making my table 3, 3, 3, and I choose these others. Does that make sense? Okay. Yes?
Wait, so for the table for x is less than 3, isn't it not as x is less than or equal to? So how do you? No, no. It is, what you're doing is you are making, oh yeah, you're right, less than 3. Well, no, you're still making your table in that same way. We're temporarily pretending it's x equals 3, because that's going to still be your boundary line. That's about your boundary line. And so you're still doing 3, 3, 3. Does that make sense? On this one, we're still doing x and y. This is -2, -2, -2, 0, 1, 2. But this one's going to be dashed. And this is going to be 0, 1, 2, right? And this is going to be dashed. Does that make sense? We're still drawing on that boundary line, but the dash shows that it's non-inclusive. Okay, yes, Elise.
Do you have to use 3 colors works for these? Or just...
Yeah, in this situation, if you have 3 inequalities, you're using the 3 different colors. You know? So you really need to see where that triple shading is. Sometimes if it's really hard to see, you might need to say, draw a line and say, this is the solution. Does that make sense? At the bare minimum, you're showing an arrow, but sometimes I've seen others that didn't, like I couldn't see their boundary lines. So you need to make it. Now, what if I'm writing the system? What happens if I'm given the graph? Okay. I'm noticing this is a vertical line. We're going to finish this. I'm going to make a table. Please do not pack up until we finish this. Okay, I'm going to take 3 points. What are these 3 points?
0, 1, 2, 1, 2.
No, what is the ordered pair?
Negative 3, 0.
Negative 3, 0.
Negative 3, 1. Oh, yeah. And
1 and negative 3, 2. Okay, so what is this one? What's a constant?
3. Negative 3.
What? What is negative 3? X. So I'm doing X is...
Attention all Millikan students. Because of the inclement weather, the PE area...
X is what? Is it greater than or less than negative 3? Where's the shading on that number line? This is a number line. Here's negative 3. So X is greater than negative 3. The other one, we're going to write it. Give me the 3 points. What are they? 2, 0, 2, 1, 2, 2. So what is this one going to be? X
is
less than 2. That's your system. Do you understand? You would write X is greater than negative 3. X is less than 2. Yes.
Isn't it?
Oh, and less than or equal to 2. Do you understand? Okay, let's try the next one. What's my M and what's my B? Let's try number 2. Let's go with 1 minute. What's the M? First, let's go. Oh, I don't like that. Let's go here. Let's first do my M is what?
2. Negative 2.
M is, okay, you're talking about for this one. M is 2, and my B is what? 1. So this is Y equals 2x plus 1. Now, if I were to continue the shading, would it be above or below?
Would be...
Look at the y-intercept. Is it greater than or less than that y-intercept? Greater than. On the y-axis, it's greater than. So y is greater than or equal to 2x plus
Attention
1.
students.
Keep
the
going.
library is closed today for nutrition
Really?
and lunch. Again,
Okay, next
attention
one.
Students, library is closed for nutrition and lunch today.
Okay, next one. What's my M, what's my B? Guys? B is negative 2 and my M is negative 1. So y equals negative x minus 2. Now, if I were to continue the shading, is it shading above or below that y-intercept? So it would be less than, and it's just going to be like that. Okay, that's how you write. All right, that's the